Hello everyone, my name is Alexey, and today we are diving into an interesting algorithmic problem that frequently appears in coding interviews, known as Maximum Subarray Sum problem. This challenge tests not only your ability to write efficient code, but also your problem-solving skills. In this video, we will explore the problem statement, understand the logic behind the solution, and walk through the code step by step. Whether you are preparing for a technical interview or just eager to enhance your coding skills, this video is designed to provide you of clear understanding how to tackle this common coding problem. Please like, and let's go to the practice. Amazing, let's acquire this problem statement. We have to solve maximum subarray sum problem. So we have to write a function max subarray sum that takes an array of integers as input and returns the maximum sum of a subarray. Let's look at the examples. In the first example, we will pass this array into max subarray sum function, and we will have 6 as our result, because we will have 4, -1, 2, and 1 as a subarray, and it will be a subarray with maximum sum. And the sum will be 6. Cool. The same thing with the second example. We will have here subarray which will contain only one element. It's -1, and -1 will be our maximum sum. And the same thing with third array. Interesting thing that subarray could be an array itself, and the sum of 1, 2, 3, 4, 5 will be 15. It was a brief explanation of our task, and let's go to the solution. I have to admit that this solution uses cadence algorithm, an efficient algorithm for finding the maximum subarray sum in a single pass through the array, so the complexity will be big O of n. I've added the article about cadence algorithm explanation in the description, so you can check, acquire with the algorithm, and then try to solve the problem by yourself, and it will be extremely useful for you. You can pause the video and solve this, and then compare with my code. So this was a small digression. Let's move on to the solution. And let's start our solution with processing one corner case if we will pass empty array in our function. So we have to check the length of our array, and if it will be 0, we have to return 0, because maximum sum of the elements of this array will be 0 because it's empty. So if array length equals to 0, return 0. Cool. Then let's initialize our main variables, and first variable will be max sum, so let max sum, and with this variable we will keep track of the maximum subarray sum found so far. And let's start it with the value of the first element of the array. So looks logical. So r and 0. And this variable we will return as a result later, after our all operations. And second variable will be current sum. So let current sum. And with this variable, we will keep track of the sum of the current subarray being considered. And let's start it with the value of the first element of the array. So r 0, the same. And next part will be writing a loop. It's maybe the main part of our function, and let's do it. Let's implement our loop, and I want to say that you may not understand the logic from the first time, and later, after writing this code, I will return to this moment with deep explanations, with images and additional words. So don't worry if you won't understand it from the first time. All is okay, and we will return to it later. So let's start a loop from the second element of the array, index 1, since we've already initialized max sum and current sum, so we processed this first element of the array. It's our mini optimizations. So for let I equals to 1, I less than array length, and we will increment our I. In the body of our cycle, we have to update our current sum. So current sum equals to math max r I, and we will compare it with current sum plus r plus current element. Nice. So for each element in the array, we have to update the current sum to be the maximum of the current element, or the sum of the current subarray plus the current element. This step is crucial for finding the maximum subarray sum. And after update of our current sum, we have to update our max sum. So max sum equals 2. And here we will compare max sum, previous max sum, and current sum. We have to update max sum by comparing the max sum with current sum, and if the current subarray sum is greater, it becomes new maximum. So math max current sum and previous max sum. Nice. And that's it. We will process all elements with this loop, and then we have to return our max sum, our variable, so just return max sum. Cool. And that's it. This algorithm efficiently tracks the maximum subarray sum in a single pass through the array, making it a good solution for this problem. Okay, and now let me explain why we are updating current sum and max sum in this way, and the core logic of this solution and this algorithm. Okay, it's time to explain this logic more deeply, as I promised, and let's consider first example. Let's suppose we passed this array to our function, and let's move step by step with explanation. So firstly, let's talk about initial variables. Our max sum will be -2 initialized with the first element, and our current sum will be -2 initialized with the first element. Then let's move to our loop, and here our first I will be 1, so current element will be 1, and current sum becomes 1 because math max between 1 and -2 plus 1 is 1, and max sum becomes 1 because math max between -2 and 1 is 1. Then our I becomes 2 and current element -3. Our current sum becomes -2 because math max between -3 and 1 minus 3 is -2. Max sum remains 1 because -2 is not greater than 1. Then I will be 3 and current element is 4. So current sum becomes 4 because max with 4 and -2 plus 4 is 4. Mass sum becomes 4 because math max between 1 and 4 is 4. Then our I will be 4 and current element -1. So current sum becomes 3 because mass max between -1 and 4 minus 1 is 3, and math max remained 4 because 3 is not greater than 4. Let's move to the fifth step. So I is 5 and current element is 2, so our current sum becomes 5 because math max between 2 and 3 plus 2 is 5, and max sum becomes 5 because math max between 4 and 5 is 5. Then we will have I equals to 6. So current element is 1, current sum becomes 6 because math max between 1 and 5 plus 1 is 6, and max sum becomes 6 because math max between 5 and 6 is 6. Okay, I equals to 7. Current element is -5, current sum becomes 1 because math max between -5 and 6 minus 5 is 1, and max sum remains 6 because 1 is not greater than 6. And the last step, current element is 4, current sum becomes 5 because math max between 4 and 1 plus 4 is 5, and max sum remains 6 because 5 is not greater than 6. And as a final result, the loop ends and the function returns 6, which is the maximum subarray sum. Finally, let's check our code, and I will write node index.js in my console, and we will have as a result 6, -1, and 15. So let's compare with our test cases. So 6, -1, and 15. So we've solved this problem and acquired with cadence algorithm for finding the maximum subarray sum in a single pass through the array. So that's it. Please like, subscribe, stay tuned, please check the description, and also share your ideas about future videos. Bye.